Hi everybody. I just wanted to say hi before I start with the lesson. This is topic 7.1, which is about recognizing a function. And my dogs are a little rambunctious tonight, so you might hear them barking or wrestling in the background. Sorry about that. All right, let's go ahead and get started. In section 7.1, there's a lot of vocabulary that we're going to talk about. So the first term that you need to know is a relation. And a relation is not that. A relation is any set of ordered pairs. So again, a relation is any set of ordered pairs. Now I'm going to go through these fast, so you'll probably have to pause the video to catch up on your note-taking. The next term is input, and that is also called the domain of a function. And it is the x-coordinates of a relation. And we will go through some examples to explain that. The output is also called the range, and it is the set of y-coordinates in a relation. Sorry about that. A function, the function is a relation in which every input is paired with exactly one output. And we have an entire course dedicated to studying functions in high school, so that's a very, very important term that you know. And finally, we have a mapping diagram. And this is a little bit longer, so you'll probably take up a couple lines there. A mapping diagram describes a relation by linking input values with their corresponding output, with their corresponding output values using arrows. So I want to take a note here that in a mapping, we do not repeat numbers in the input box nor in the output box. So here is a mapping diagram. We have our input box and our output box. We do not have any numbers repeating over here. So if I had 3 4s, I would only put just 1 4 down. Don't repeat the numbers. That's what that means. And here I don't repeat any numbers in my output box. So let's talk about this a little bit more. This is a mapping diagram, and this mapping diagram describes the relation 0, 0. So that's the first point, 0, 0. Remember, inputs are your x's, outputs are your y's. So we have 0, 0. We have 1, 8, because of here the input is 1, the output is 8. And you can see that those correspond to all of these. Now, this is a function because every single output has one single arrow going away from it to one number in the output. So since every input is matched with exactly one output, it makes it a function. Now you have some examples at the bottom there, and you are supposed to match each relation to its mapping. So we want to look for the point 0, 1. So 0 is the input, 1 is the output. So that occurs here, it occurs here, and it doesn't occur here, so that's out. Then I look for the point 1, 2. This is negative 1, 2, so that's not right. Here it goes from 1 to 2, so this is right. And then we have the point 2, 2, so here's 2, it goes to 2. And the point 3, 4, here's 3, and it goes to 4. So A is matched with this middle diagram. So I'm going to put an arrow there. If you take a look at the second one, part B, we have the point negative 2 matched up with 3. So negative 2 is matched up with 3. Then negative 1 is matched up with 2. 0 is matched up with 1. And 1 is matched up with 0. So this mapping matches that relation. So let's put an arrow going there as well. And then part C, obviously there's only one more choice here. If x is 1, then y is -1. So here's my x, and it's matched with -1 for the y. I also have 1 matched with 1. 4 is matched with 2, and 4 is also matched with -2. So C pairs up with the mapping right below it. Now it's not on our papers, but we are going to describe if each one of these is a function. So is the mapping a function? So for this mapping here, we have an x going to 1y, this x goes to 1y, this goes to 1y, and this goes to 1y. So it matches our definition. Every single x is paired with exactly 1y. So this one is a function. So I'm going to put yes, because each x is paired with exactly 1y. All right, let's take a look at the next one. So in this one, this x is paired with 1y, this x is paired with 1y, this x is paired with 1y, and this x is paired with 1y. So this here is also a function. So I'm going to do the same thing there. Each x is paired with exactly 1y. Let's take a look at the third one then. So here, the x value of 1 is paired up with -1, but it's also paired up with 1. So this x is paired up with more than 1y, so this one is not a function. So you should write down that this third one here is not a function because x is paired with more than 1y. At the top of the next page, I would like for you to complete example 2 on your own, as well as explaining why this one is a function here, but this one is not. So look at your notes that you've already taken, and I would like for you to complete that on your own. For example 3, we're going to do this together. We're going to determine if each relation is a function by using a mapping diagram to help you determine the answer. So remember, our inputs are our x values. So I'm going to put 0, 1, 2, and 3 in for my inputs. Then I'm going to look at my y values for my outputs. That's 1, 4, 5, and 7. So I'm going to fill out my outputs with 1, 4, 5, and 7. Then to complete the diagram, I draw arrows from each x to the y that matches up with it. So 0 goes to 1, 1 goes to 4, 2 goes to 5, and 3 goes to 7. So since every single x that I have pairs up with exactly 1y, that makes it a function. So the answer is yes. Moving on to the next example, we have x values of -2, -1, 0, and 1. So I put those in my input box. -2, -1, 0, and 1. if I take a look at my y values, they are 0, 0, 0, and 0. But remember, I don't repeat numbers in my output box, so I'm just going to put a 0 once and not fill out the whole thing. And to finish up the diagram, I'm going to draw an arrow from each x to the y it matches up with. So -2 goes to 0, -1 goes to 0, 0 goes to 0, and 1 goes to 0. So that's what the mapping diagram looks like. And now I have to decide if it's a function. For every x that I have, it's only matched up with one number here. It doesn't matter that all of these go to the same number. All that matters is that for this x, it's only paired with one number. This x is only paired with one number. So because of that, it is a function. And for part C, we're going to take the x's of 0, 0, 1, and 3 and put them in the input. But again, I don't repeat numbers. So since I named 2 zeros, I only put 1 0 in my mapping diagram. So it's going to be just 1 0, and then 1 and 3. My outputs are -1, 3, and 2, and I typically want to write those in numerical order. So I'm going to put -1, and then in numerical order the next number would be a 2, and then a 3. And now my job is to draw arrows that match each x with the y that goes with it. So 0 goes with -1, 0 also goes with 3, 1 goes with 2, and 3 goes with 2. So that's what the diagram looks like, the mapping diagram looks like for part C. Is this a function? I see that this x value is paired with 2 different y values. So because 0 is paired with 2 different y values, this is not a function. Moving on to the tables, we want to know if these are functions or not. And I look at my x's. The x matches with 3. The x also matches with 2. So the same x matches with 2 different y's. Now this is a table, not a mapping. So in a table, we do repeat numbers. In a mapping, we don't. So because x value of 1 is matched with 2 different y's, the answer is no. In the next one, if you notice that the x values are all different here, so that means each x has its own y that it's paired with. It doesn't matter that it's the same y, just like it didn't matter up here. So every x has exactly one y that's paired with it, so this is yes. The next table has 0 paired with 14, 1 is paired with 16, 2 is paired with 18, and 3 is paired with 20. None of these repeat, so that means that each x has its own y, so that is a function. And last, we have -5 matched with -5, -3 matched with -3, -1 matched with -1, and 1 matched with 1. So each of these x's is matched with exactly one y, so this is a function. So this is yes. This last page of notes talks about how we can identify if a graph represents a function or not. And since a function has exactly one y for every x, in other words, every x has exactly one y, we can use what is called the vertical line test, and we abbreviate that VLT, to determine if a graph represents a function. So what we do is we take our pencil and when we have our pencil here, we're going to slide our pencil across the graph. So I take my pencil and I slide it across the graph. As I do that, I want to see, does the pencil hit the graph in more than one spot? So this one, every time I move my pencil across the graph only touches it once. Because of that, this is a function, so we say it passes the vertical line test. So we are determining if it represents a function. This first one does, so we would say yes. I'm going to grab my pencil and I'm going to move it across part B's graph. So it's made up of a bunch of points. So it hits there once, it hits there once, it hits there once, and there once. But right here, it hits twice. You see that it hits the point right here and right here. So because it hit my pencil twice, it fails the vertical line test, and therefore it is not a function. So we would put no for this one. Let's continue with the pencil. So we're going to take our pencil and we're going to drag it across the graph. It has to be vertical like it is. So again, if I take it across the graph, it only touches the graph once every time I move it across. Because of that, this passes the vertical line test, so we would say this is yes, a function. Now I'm going to take my pencil and I'm going to come down to this next graph down here, and if I move my pencil across, it hits once there, but then it starts hitting twice. So it hits both here and it hits my pencil here. So whenever it hits more than once, it fails the vertical line test. So that means that this is not a function. So we're going to put no here. Continuing on, we're going to drag the pencil across this graph, and everywhere it hits, it's just once on my graph. So that means that this is a function. So this one is yes. And the last one. So I'm going to take my pencil. It hits once there, but it hits twice there, hits twice there. So hopefully you can see that. It hits here, and it also hits there. So when it hits more than once, it is not a function. So this is no. That is the end of the notes for section 7.1.